So what I want to look at in this lesson is the stars. So when you look up the night sky, you see this point of light. Have you ever asked yourself the question, what exactly is a star? And that's kind of like what I want to talk about within this lesson. This here, and a lot of this might be alien to you, but it's generally the life cycle of a star. So it goes through this process. What I kind of want to talk about today is this step here up to this step here, up to the formation of a star. And then in subsequent lessons, I'll talk about these other steps here. So the first thing we want to think about is like what is a star? So star is a luminous object, and we know this when we look in the sky, we can see them because they're luminous. So it's a luminous object. So luminous object. Okay, so it gives off light. It's made of gas. Okay, so it's made of gas, and it can produce its own light. And it can also produce its own heat by what are known as nuclear reactions. So really a way to kind of think about a star, it's not just one thing, it's more of a process. It's more of a process. That's kind of like what a star is. It's an ongoing, if you like, nuclear reaction that's happening in space. So what I want to think about then is I want to think about like how does it form? How does a star form? So first of all, it's made up of a gas. So what gas is it made up of? So what we have, we start off with hydrogen. So we have hydrogen atoms. So if we look on the periodic table, so hydrogen is the first element on the periodic table. And let me just get rid of some of this stuff. So if we look at hydrogen, it's the first element that's on the periodic table, and it's a very simple element. It's made up of one proton and one electron. So if we go back here, so what we start off with then is hydrogen. So hydrogen, a way to kind of think about it is hydrogen is just made up of a proton. So its nucleus is just one proton. So something like this. So what we end up is we start off with a gas. So we have hydrogen. So imagine these are all hydrogen. And they're all just in space, okay? Now I'm only putting a couple of hydrogens here, but what you can imagine within the depths of space, you have a huge, like billions and billions and billions of these hydrogen atoms just floating around as a gas. So if we look at this here, what we have is, so this is kind of like what it looks like here. So you have what's known as a nebula. So all this really is just lots and lots and lots of hydrogen just moving around in a gas. Now what's going to start to happen? So gravity. So the force of gravity. So gravity is going to start to pull these hydrogens together. So they're going to start to come together. And as they start to come together and they start to form a clump, so you can imagine then what's going to happen is you're going to, let's say all of these hydrogen atoms are very close together. So you're going to get this like a ball of hydrogen gas. These are all going to be very, very close to each other. And then outside here, you're going to have all of the other hydrogen atoms. So what's happening is gravity, as this clump gets bigger, the force of gravity increases. So remember, the more mass an object has, the more gravity it has. So what happens is, as these particles start to come together, hydrogen, they form into this like a clump. So they do in the middle, let's say, of this nebulous or nebula. And as they come together like this and they start to form, the mass starts to go up, and therefore the force of gravity starts to go up. So as a result of that, it's going to attract more and more hydrogen, let's say, into the core. So what's going to happen is you're going to have the force of gravity pulling everything into this center here. And as gravity starts to go up and all of these hydrogen atoms start to hit off each other and rub against each other, the temperature starts to go up as well. So temperature increases. And it increases to a huge amount. And what will also start to happen is this ball will start to rotate. It'll start to get momentum and it'll start to move. And as a result of this, what's going to start to happen is the gravity will continue going up, temperature will continue going up because you have all these particles rubbing off each other, causing friction, and the temperature it starts to get hotter and hotter and hotter, and it starts to spin and starts to rotate. So the energy, if you like, it starts to increase, let's say, within here, within this massive gas ball. So this is going to happen for a period of time. Now, if we think about it, so if we think about hydrogen, so imagine we look in here, so we're going to have billions and billions and billions of hydrogen atoms all swirling around in here. So if we think about a hydrogen atom is just a nucleus, it's just basically a proton. So if we think about these two charges, their protons are positively charged, so these are actually going to repel each other. So under normal conditions, what will happen is the hydrogens will actually repel each other. The electrostatic force will, so what's going to happen is, in order to overcome this electrostatic force, we need high gravity. And that's what starts to happen when this starts to build here. So what you're going to have is, you're going to have gravity pulling, let's say, more and more hydrogen into the nucleus. And what will happen is when these, so essentially what's happening is the pressure is also going up as well. And when the pressure goes up, what happens is these protons or hydrogen atoms are going to be forced closer and closer together, like so. They're going to be forced closer and closer together, and this like repulsive force is going to be overcome, and then what's going to happen is you're going to have what's called a nuclear force, and this nuclear force will actually bind these two hydrogen nucleus, or these protons together, and this is what's known as fusion. And it's actually a nuclear reaction. So what will happen is you're going to go from having, let's say, these two protons separately, they're going to be combined into a nucleus that has two protons together. And if we think about the nucleus that has two protons, we're talking about helium. So what will happen is you're going to get hydrogen is going to be fused into helium. So you're going to have hydrogen, and it's going to, so let's say you'll have two hydrogens like so, and then it's going to react together, they'll be forced together, and it's actually going to turn into helium. And this process will release a huge amount of energy. A huge amount of energy. And this is what's known as a nuclear fusion reaction. So essentially, when conditions get just right, let's say within this nebulous, what you'll get is the formation of what's known as a protostar. So essentially what this is it's going to have this accretion disk all around it. So you'll have, in the middle, you'll have this, you'll have hydrogen atoms being forced together and them moving around and around, and the temperature increasing and the pressure increasing as well. That's what's going to happen inside here. And you're going to have a strong force of gravity, and it's going to be pulling as much as it can, let's say, into it. Now what will happen is, if these conditions are just right, so if there's enough gravity and the temperature is right and there's enough pressure, what's going to happen is the energy will actually push hydrogen atoms, the nuclei of hydrogen atoms together, and it'll overcome the natural tendency of these repulsive forces. And what will happen is the nucleuses will actually start to fuse, and then when that happens, you're going to have this fusion reaction that's going to start to take place within the core of this protostar. And once this fusion process starts to happen, it starts to generate a huge amount of energy. So what's going to happen then, if you think about then a star, so imagine you have the core, so this is the core of the star, and remember this is like it's essentially like a gas, like chemical reactions happening inside the core, and then outside you're going to have, let's say, other layers of the star. So in the core, gravity is very high, temperature is very high, and pressure is very high. And what these will do is these will generate a force, let's say, that's pulling everything into it, like so. So the gravity is going to pull everything, it's going to start to pull everything into it. But then once this ignites and once this process here starts to happen, where you have a nuclear reaction, this nuclear reaction is going to generate an outward force. So you're going to get an outward force like so. So essentially what's happening is you have gravity is pulling everything in, but then the outward force from these nuclear reactions that are happening, it's pushing everything out. And what starts to happen then, when this starts to happen, you start to get this stable, you get a stable star happening. Here. So these are what are known as, it's called a main sequence star, which has, like, so depending on the mass that you start off with, if you have a really big massive dust cloud, and you have, let's say, low mass, you're going to have a main sequential star. So you can have ones that have low mass, now that's relatively speaking, so low mass, and then you can have ones that have high mass, which means that they have a lot of hydrogen starting off. So you get then what are known as a main sequential star, and essentially what's happened here is this process is kind of stabilized. So you have a nuclear reaction happening in the core of the star, it's fusing hydrogen together, making helium, and it's generating huge amounts of gravity that's pulling everything into it. And what's happening then is this nuclear reaction, so it's kind of like a fusion reaction, like a nuclear explosion, it's pushing everything out. So gravity is, and what happens is you get a kind of an equilibrium that happens. So there's an equilibrium between gravity pulling everything in and the nuclear reaction explosions pushing everything out. So this levels off, and then you get this kind of a stable formation, which is known as a main sequential star. Now our sun is like this at the moment. This is the stage that it's in. Now what will happen is this like stable formation will continue happening, and this outward push and inward push, this will continue happening while there's enough fuel, so while there's enough hydrogen. So as long as the star can continue fusing hydrogen atoms together and generating all of this energy, what's going to happen is the force of gravity, crushing the star in will be pushed against by the force of the energy that's being pushed out from the nuclear reaction. So that's the first, let's say, stage of a star's life cycle. So just as a kind of, so if we think about this, so this is the stage that our sun is in. So they're luminous objects. So where is the luminosity coming from? Well, you have these nuclear reactions happening. You've hydrogen being fused together, making helium, and that's giving out huge amounts of energy. So it gives that energy out as heat and light, and that's what you see here. It's made of a gas. So essentially what it is it's made of hydrogen. It starts off with hydrogen as a big cloud of hydrogen gas. It gets fused together and you get helium. Now you also, as the star continues on in its life process, you start to get other elements formed as well. It produces its own light. So it produces its own light, and it produces its own heat by nuclear reactions. So the heat that's given off is given off by the fusion of hydrogen atoms together. And this heat and light that's given off from this nuclear reaction is the light that we see. When you look at the sky and you see a star, for example, you're seeing light being generated by this process. And also the energy that's formed, this energy that's produced through this nuclear reaction, is very important to the life on the Earth as well. It keeps our planet warm, and it provides, the right conditions to keep everything alive on our planet, to keep temperatures where they need to be. And you can think about these two phases here, you can think about these as two distinct phases. So you have phase one, and phase one is what's known as formation. So formation then, if we think about what's happening in formation, so there are large gas clouds in space called the nebulae. So that's what these gas clouds are here. So you have these huge gas clouds here that are formed. The attractive force of gravity of the gas particles causes these gases to collapse and come together. So remember, you have hydrogen, you have these start to come together, gravity starts to bring them together. It creates like a ball of hydrogen, and as that ball continues to increase, it's like a snowball effect, gravity starts to increase as well, and it pulls more and more particles into it. As the temperature and pressure within the cloud increases, so as all of these come together and they start to rub off each other and they start to rotate, the temperature starts to increase. So as the temperature and the pressure also increases as well. So as the temperature and pressure within the cloud increases, the gas begins to spin rapidly, which causes the nuclei of elements to join together. And this is what's known as a nuclear fusion reaction. And this is what starts to take place, and a star is born then, essentially. So once it ignites and you get this fusion reaction happening, you can essentially say that we've created a star. So that, let's say, that's kind of like phase one, is formation. And then phase two then, so phase two is what's known as the stable period. So the stable period. So over billions of years, the star becomes stable, and we call such a star a main sequence star. So once this process stabilizes, and it can take billions of years for it to go from here to here to here, and we get this stable process that's happening, and we call this a main sequence star. A star spends the majority of its life as a main sequence star, and it is in this phase that the star is using up all its available resource of hydrogen in nuclear reactions to emit heat and light. So what's happened here is all of this hydrogen is being consumed and it's being converted into helium as part of a nuclear fusion reaction. And you get light and heat being emitted. A main sequential star balances between its own gravity trying to shrink it. So again, remember, we have gravity trying to pull everything in, and the heat energy that it is produced trying to make it expand. So the heat energy, so this nuclear reaction is causing this heat energy to be formed, and it's trying to expand the star, but the force of gravity is trying to compress the star. The star in this form will continue to grow for billions of years, and our own sun, as we're saying, is in this phase of its life as well. So this process then can go on for billions and billions of years, the burning of a star. So what I'll do is in the next lessons, we'll start to look at what starts to happen then when the fuel runs out. So we start to move into these stages, let's say, of the life cycle of a star, and we'll talk in more detail about them in the next lesson. Okay, so thank you for listening.